Hey algebra students, here are your 7.4 part 2 notes where we are going to be graphing our transformations of functions. In this first graph, you might notice that we have already been given our parent function graph. So what we need to do is make sure that we identify what is our parent function. So remember, your parent function is always just y equals b to the x. So what I'm going to notice is y equals 5 to the x plus 2 plus 3. Here is my parent function, which is just 5 to the x. So I'm going to write 5 to the x. Now, when we are looking at our growth or a decay, you can already tell just by the graph that my graph is moving at a growth. And we can also tell because my b value is 5, which is greater than 1. If I'm looking for my stretch or my shrink, I'm looking for the letter A. So when we expand this out, what this really looks like is y equals 1 times 5 to the x plus 2 plus 3. And because my stretch, my A is 1, 1 doesn't do anything to your numbers. So we don't actually have a stretch or a shrink because 1 times anything is just itself. So now what we're going to do is we are going to graph. So we are going to pay attention, looking at our graph or our equation. We're going to identify our h and our k. Remember that h lies, so when I see a positive 2, what really is there is a negative 2. And because we've got an h is horizontal, so we're going left 2. I'm going to identify my k, which is a positive 3 in both scenarios. So what I'm going to do is take that for what it is because k tells the truth. And because it's positive, I'm going to go up 3. So that means the 2 dots on my graph, I'm going to do exactly what our shifts tell us. I'm going to go up 3 and to the right, or left 2. So each graph is up 3, 1, 2, 3, and to the left, 1, 2. So I have a new dot here. My next new point, I'm going to move up 3, 1, 2, 3, and to the left 2, 1, 2. So my new dot is here. So now what I'm going to do is I'm going to graph, but notice that our asymptote originally started at 0. So when I move my asymptote, it's going to stay just 1 below my dot. So that means my asymptote now just moved here. Okay, and what we can also notice is that because we're moving up 3, my asymptote started at 0, but it also got moved with its graph. So my asymptote moved from 0 also up to 3. So our k is not only just an up shift, it also tells us what our asymptote is, which is pretty cool because if we move our graph up, our asymptote goes with us. So when I graph my new line, I have to make sure that I do not go past my asymptote, which is now at a positive 3. So let's go ahead and fill out our information. Did we reflect this graph at all? The answer is no. And we could also look at our equation and notice that I don't have a negative a, so no reflection. I'm going to go ahead and skip my y-intercept for now because if you guys notice, after our transformations, I can't really see my y-intercept. So we're going to have to solve for that here in just a second. We just talked about our asymptote, which is y equals 3. And the reason we write it as a y equals is because you're telling me what horizontal line is the asymptote. So it's y equals, it's a HOI. My domain will always be all real numbers because it'll continue to grow in both directions from left to right. But our asymptote, because we moved it up, that's our point that we can't cross, so our range is also going to change. And so if our purple graph is only hitting all of the y values that are greater than 3. So now, going back to our y-intercept, I cannot see it on my graph. I don't know where it perfectly crosses. So what I have to do is use our equation to help us find the y-intercept. So when we have our y-intercept, we know that the x value is always 0. So we can put that in. So now when we have our equation, what we're going to do is plug in a 0 for x and solve for the y-intercept. Okay, so we're taking our equation, y equals and we are solving. So 5 to the 0 plus 2 is now 5 squared plus 3. Y equals 25 plus 3. So my y-intercept would be all the way at 0, 28, which makes sense because my y values are getting bigger and bigger as we go. Okay? Looking at our next problem, again, we were given the parent function, so all we have to do is identify our information, use our shifts to move, and answer these questions. So looking at this graph equation, my parent function is just y equals 1/2 to the x. Now, that negative does not belong to our parent function because if we stretch this out, this really is -1 times 1/2 to the x minus 3 minus 2. So we got to be careful. So when we're looking at a growth or a decay, we know this is a decay because the b value is less than 1. If I look at my graph, my equation, do we have a stretch or a shrink? So my a value, I don't care that it's negative. The only thing that this negative tells me is whether I have a reflection. So because I have a reflection, I can say yes because it's negative, but that 1 does nothing. It doesn't change my 1/2. So that a value, which is just a +1, doesn't stretch or shrink my graph at all. Okay? So now we're going to go ahead and use our shifts to move. So if I see a -3 for my h, what really is there is a +3. So that means I'm going right 3. I'm going to take my k as it is, and my k is a -2, which means I'm going down 2. So what we're going to do next is reflect our graph. I've got -4 because it was at a +4. I now have a 2, which should now be -2, and I have a 1, which would now be 1. So I'm not going to put a line through here, but what I'm going to do now is just go ahead and move my graph down. Okay, so all of our new points, our reflected points, those are the ones we're going to move down 2, 1, 2, and to the right 3. 1, 2, 3. I'm going to go ahead and move my next point down 2 and to the left 3. 1, 2, and to the, right 3. 1, 2, 3. So here's my new point. And then I'm going to go ahead and move my last one. 1, 2, and to the right 3. 1, 2, 3. So now we have our new line, but don't forget our K helps us also identify our asymptote. So if it started at 0, even if I reflected, my asymptote is still at 0. So even though I went down 2, my asymptote is still going to be here at -2 because we still went from 0 down. So my new graph is not going to go past that -2 point. Okay? So now what we can do is answer all of these questions about our new purple graph after we reflected. So my asymptote is y equals -2. My range, my domain is still all real numbers. But notice, because we flipped and we reflected, my graph is now going to be less than -2, not greater than. We're getting less. I still can't see my y-intercept, so what I have to do is know that x is technically 0. So we're going to plug that into the equation, y equals. And because I see that negative sign, I'm going to go ahead and leave it as -1 times 1/2 0 minus 3 minus 2. So let's go ahead and solve. Y equals -1 times 1/2 to the -3 minus 2. Y equals, now we're just doing order of operations. A negative exponent flips my fraction, so now I have 2 to the 3 minus 2. And you don't have to write all this down. I'm just showing you all of my steps so that you know what's going on. 2 to the 3rd is 8. -1 times 8 is -8 minus 2. So my y-intercept moved all the way down to -10, which makes sense as to why we can't see it when we graphed our new graph. Okay, so using that equation to help us verify that we know what our y-intercept is. All right, so now what I'm going to do is I'm going to take that parent function away from you, and you're going to have to graph that first. So when we are doing our graphing, your step one, and I want you to make sure you write this down, step number one, just like up above, instead of me giving it to you, you have to do it first now. We're going to graph the parent function. That's going to be step number one. Always, always, always. Graph that parent function. So let's go back to the graph that we have and let's identify it. Remember, it is just y equals b to the x. So looking at my graph, if I stretch this out, this is -1 times 5 to the x plus 2 plus 8. So my parent function is just that b to the x. So be careful, it is not the negative. Because my b is 5, I have a growth. So when I graph it, it should be looking like a growth. Looking at my a, it is just a +1 because that negative sign tells me something different. So we'll be careful about that. So I don't have a stretch or a shrink. Now, when we fill in our table of values, we're not going to do it after our transformation. So I want you to cross that out. We're going to use our table of values with our parent function because we want to graph that first. So I'm just going to throw some numbers into my table of values. I always like to start with -1, 0, 1, 2. Okay, I've got 5 as my base, so these are going to be some solid numbers. So when I graph it, this is technically y equals 5 to the -1, which is 1/5. This is y to the 0, or 5 to the 0, which is 1. This is 5 to the 1, which is just 5. And this is 5 squared, which is 25. Okay? So when we graph, you must have 3 points at all times. Okay? You must graph at least 3 points. That'll go for your quizzes. That'll go for everything. You must graph 3 points. So lucky for you, I gave you 4. So we're going to go ahead and graph those. So I have -1, 1/5, which would be about here. 0, 1, 1 to the 5. Oops. And then notice that 2 to the 25 is not on my graph, but I gave you 4, so you at least have the ability to graph the 3 of them that do fit on your graph. Okay? So now that we've graphed our parent function, we need to go to the next piece of information. And the next most important piece, which is step number 2, is to reflect. Just like when we are solving our table of values and we're doing our exponents, you have to flip first, then do 1, 5 to the 1. Okay, we don't try to do 5 to the -1 first. We flip our whole number into the fraction and then solve the exponent. So what we're going to do is flip our parent function, then move with our shifts. So all of my positive y values just now became the negative version of themselves in the mirror. Okay, so you are more than welcome to, again, draw a line through your reflection, but I'm going to leave them as dots so that I don't get confused on what lines I'm working from. The next thing we're going to do is identify our shifts. So after you reflect, step number 3 is move either up, down, left, or right from the reflection. Okay, you don't go back up to the parent function and move from the parent function. You have to move from your reflection. So what we're going to do is identify our h and our k. So our h is +2, which means there's technically a -2 there, which means I'm going to go left 2. I have a positive 8 for my k, which means I'm going to go up 8. So each one of my orange dots are going to go up 8 and to the left 2. So I'm going to start here. 1, 2, 3, 4, 5, 6, 7, 8, and to the left 2, 1, 2. So my new dot is here. That's my 1/5. My next dot is going to move too far. 1, 2, 3, 4, 5, 6, 7, 8, and to the left 2, 1, 2. So my new dot is here. Or my new ordered pair is at -2, 7. And then my last dot is 1, 2, 3, 4, 5, 6, 7, 8, and to the left, 1, 2. Okay? So like we saw up above, our K is also our asymptote. So if we started at 0, even on the reflection, your asymptote is 0. So if we start at 0, but I moved up 8, my asymptote is now at a positive 8 because we moved it all the way up. So when I do my graph, I need to make sure that I do not go past my asymptote. So there's my graph, okay? Now, we're not fully confident on whether we have a y-intercept. So we're just going to graph as best we can and go find our y-intercept later. Because who knows, we could have hit a y-intercept, but we'll find out later if our graph is showing it correctly. So, yes, we did reflect because we had that -a. We don't know what our y-intercept is, but what we're going to do is answer all of these questions after our transformations. So these happen after the transformations. Oops. So looking at my asymptote, we moved it up to where y equals 8. Domain is always my range, my domain is all real numbers. And because we reflected, we are now going less than y, but we are not going to touch 8, so we are less than 8. So now what we're going to do is I'm not sure where my y-intercept is because I didn't put a point on the y-axis. So I'm going to use my equation to find that y-intercept so that I have a perfect number. And when I do that, I am going to make sure that I use the -1 times 5, and I'm going to plug in my 0 for x plus 2 plus 8. So now we're going to solve. Y equals, and we're going to do this pretty quickly, -1 times 5 squared plus 8. 5 squared is 25 times -1 is -25 plus 8. So my y is -17. So my y-intercept is 0, -17. So when I go back to my graph, it makes sense that I don't cross the y-axis when I draw that line through that graph. So a pretty heavy question, but it covers all of our bases when we are graphing our functions. Last question, number 2 in the graphing section. First things first is always to identify your parent function, which is always just b to the x. So we have y equals 1/2 to the x. My b value is less than 1, so I'm going to have a decay when I first graph. My a value is 1, so I don't have a stretch or shrink because my a value doesn't do anything to the number. We're going to use our parent functions for our table of values. Now notice, because we have a fraction, our table of values can look a little bit different than our last problem. So know that when you put a negative exponent in, it flips your number or your common ratio, it'll flip it on its head. So if we have a fraction, let's use some negative numbers so that we can flip that fraction. So when we're graphing, we're only dealing with whole numbers and not fractions. But also make sure that you include your y-intercept, so we're going to include that 0. So now when we graph, we have y equals 1/2 to the -3, which is technically 2 to the 3rd, which is 8. I have y to the 1/2 to the -2, So flip your fraction. You have 2 squared, which is 4. Y equals 1 over 2 to the power of -1. Flip your fraction, so you just have 2 to the 1, which is 2. And then anything to the power of 0 is 1. So now when we graph, we have all of these beautiful numbers. We have -0, 1, 1, 2, -2, 4, and 3, -3, 8. When we're graphing the parent function, the asymptote is always 0, so we are not going to go past 0 when we graph our parent function. The step 2 was to see if we have a reflection, because we'll have to graph that, but lucky for us, there is no reflection on this function, so we don't have to worry about that. All we have to do now is worry about our shifts. So when I see my h, it looks like a -1, but it really is positive. So I'm going to go to the right one. I have my k, I take it as it is, so it's -4, which means I'm going down 4. So now we can go ahead and shift. So I'm going to take each dot and go down 1, 2, 3, 4, and to the right 1. Notice I landed on another dot, so be careful. When I move this next point, I'm not moving the purple one, I'm moving the red one behind it. Down 1, 2, 3, 4, and to the right 1. Here's my second purple dot. Taking my next one, 1, 2, 3, 4, and to the right 1. Ooh, notice you guys were crossing the y-axis, so we'll be able to see our y-intercept this time. And my last one, 1, 2, 3, 4, and to the right 1. Okay, don't forget that when we shift down, our asymptote also goes with us. So our asymptote is now at -4. So when I graph my new function, my purple line should not go past -4. So let's go ahead and answer all of our questions. Lucky for us, when we shifted, our y-intercept was a dot that we got to plot. So we can go ahead and steal that from the graph. 0, -2. My y-intercept, or my asymptote moved down with us, so it's now at -4. Domain is always all real numbers, and then the range, because we did not have to reflect, it's still greater than, and we don't go past that asymptote, which is at -4. Okay? So you now know how to graph your parent functions, you know how to reflect, and you know how to shift. Have the best day.